Okay, so you already know how to find the solutions, roots, zeros, x-intercepts, whatever you want to call it. You already know how to find those for quadratics by looking at the graph. Now we're going to solve quadratics by factoring. So consider this. A times B equals 0. If this is true, what must be true about A or B? Well, one of them must equal 0. The same holds true for other factors. For example, if you had this, t minus 2 times t plus 3 equals 0, that means that t minus 2 or t minus 3 has to be 0, has to equal 0. So what value of t could we put here or here to make this equation true? Well, if I put a 2 right here for t, 2 minus 2, isn't that 0? And if I put a 3 right here, I'm sorry, a negative 3. If I put a negative 3 right here, negative 3 plus 3, isn't that 0? So what values of t will make this true? 2 or negative 3. Those are your solutions. In other words, it's always the opposite of whatever number is sitting here. Since that's a negative 2, one of your solutions is positive 2. Since that's a positive 3, your other solution is negative 3. So like if you were to graph this, you don't necessarily have to write this on your paper, I'm just kind of showing you. If you were to graph this quadratic, it would obviously come out as a parabola because of the t times t making t squared. And it would cross at negative 3 and positive 2. It would cross here at positive 2 and here at negative 3. All right, so in your notes it says solve by factoring in that little rectangle, set the equation equal to 0. So if you look at the first example on your page, x minus 5 and x plus 6. Since all this stuff is together on one side with 0 on the other, that's a good thing. If there were other things over here where the 0 is, we would have to move them over here to join their buddies. Then in your little rectangle it says factor the polynomial, which that's already been done. And then set each factor equal to 0. Now you really don't have to do this, but just to kind of show you what they're talking about, x minus 5 equals 0 and x plus 6 equals 0 is what it would look like if you pulled it apart. And then to figure out what x is, you get your minus 5 alone by adding 5 to both sides. So x equals negative 5. Oh, my bad. X equals positive 5. Sorry. But again, you don't have to go through all of this mess because obviously, I told you earlier, the answer is whatever the opposite of this is. Since it's x minus 5, one of your solutions is positive 5. But again, just to go through the motions and show you algebraically how you're getting that, see? So x has to be negative 6, which we know is obviously true because I said it would always be the opposite. So since that's positive 6, the answer is negative 6. So again, if you were to graph them, and you don't have to, I'm just showing you. If you were to graph it, the two solutions, roots, zeros, whatever you want to call it, would be negative 6 and positive 5. I didn't do a very good job there. 5 and negative 6. All right, let's try another one. plus 5, z plus 7. So rather than going through all that mess, just check. Is everything hanging out together on one side? All you have over here is 0? Fabulous. Since that says z plus 5, one of your solutions is negative 5. And since that says z plus 7, your other solution is z equals negative 7. And the way we write that, by the way, just like you did in 9 dash, what was it? 9-2 and 3. We write our solutions, our roots, our zeros, whatever you want to call it. We write them as an ordered pair like this, but make sure you use braces instead of parentheses, because if you just use parentheses, people will think that's a point, like on a grid. Okay, let's try another one. Y minus 4 times y minus 4. Notice everything's on one side together, so you don't really have to do anything other than identify what you could put right here for your y's. Since it's y minus 4, our solution for this would be positive 4. Interestingly enough, it'll be positive 4 over here too. So we don't write 4 twice, we just write it like this. Does that make sense? I hope so. Okay. 2x minus 3, x plus 1. Okay, everything's hanging out together on one side. See, all we have over here is 0. That's a good thing. This one's easy. Obviously, the answer here is negative 1, because it always has to be the opposite. But over here, we run into a little bit of an issue, because we can't just say, oh, the answer is the opposite of the negative 3, because we have this guy here, the 2. So this one, I'll show you how to do it the long way, and then I'll show you kind of like the cheating way. So again, you can do it like that, set it up as an equation equal to 0, and then just solve it. Add 3 on both sides. And then divide everybody by 2. At some point, you may get good and just realize, okay, well, I know it has to be the opposite. So instead of minus 3, it's going to be positive 3. And then the 2 just goes underneath. See? So your two solutions then are negative 1 and 3 halves. Oops, that was my parentheses. All right. Well, let's try another one. Okay, so you have 3x minus 1 and x minus 3. They're all together on one side, so that's easy. We know this one obviously has to be positive 3 since it says x minus 3. But this one, given the fact that it says minus 1, we know it's going to be a positive 1, and then the 3 goes in the denominator. And if you're not comfortable with just, realizing that, okay, well, if it says minus 1, I make it a positive 1, and then just take the 3 and put it down here. If you're not comfortable with that, you could set it equal to 0 and solve it like an equation. That's totally up to you. I think it's easier to just kind of cheat. But if you don't feel comfortable with that, you can just, solve it like an equation with 1 and then divide everybody by 3. So you'll get the same answer either way. I just figure, why do more work than you need to? So since these are our two solutions, write it in your brackets. Braces. There you go. Alrighty. Is that it? Oh no, wait, one more. Alright, so 7n plus 4 and 5n minus 3. And everything's on one side, so that's good. We don't need to move anything over here. So I'm going to do it using my little cheating way. Since this is a positive 4, I say n equals negative 4, and then I'm going to put the 7 in the denominator. And then over here, n equals, since that says minus 3, it's a positive 3, and then I put the 5 in the denominator. So those are our two solutions, negative 4/7 and 3/5. Okay? All right, now let's look at it from the standpoint where they're not already factored for you, like they're not in their little binomials. What if you have the trinomial like this? Well, then you got to factor it first before you can get your answer. So if you recall from before, we said, okay, well, we want the factors for 15, oops, you know, this guy, and we want a sum of 8. So in other words, what could you multiply to get 15, where if you added it, you'd get 8? And my guess would be, I would assume 5 times, yeah, 5 times 3, because 5 plus 3 would equal 8. So then you just write your two binomials, x plus 5, x plus 3. And now we know what our solutions are. Since that's a positive 5, I know one of my solutions is negative 5. And since that's a positive 3, I know my other solution is a negative 3. So in other words, if you were to plot this, like if you went into your y equals and you typed that quadratic in and hit graph, your parabola, that U shape, would cross the x-axis at negative 5 and negative 3. All right, let's try another one. P squared plus P minus 20. Everything's chilling on one side together, so that's good. We don't need to move anything over. So we want to figure out factors of negative 20. And we want the sum to be positive 1. So remember, there's like an imaginary little 1 there. Let's see. I'm thinking 5 times 4, but I wonder which one needs to be negative so that this is a positive 1. Oh, that needs to be negative, because 5 plus negative 4 would give me positive 1. And 5 times negative 4 would be negative 20. Perfect. All right, so we have P plus 5 times P minus 4, which means, since that's a positive 5, one of my solutions is a negative 5. And since that's a negative 4, my other solution is a positive 4. Done. All right, one more. T squared plus 3t equals 54. Okay, so you'll notice that this time they were a little bit mean to us, and they didn't put everybody hanging out together on one side. We have this guy chilling over here where the 0 should be. Since I need to move him over to join his buddies, since he's a positive 54, I'm going to subtract 54 from both sides. So now there's nothing over there, which is good. That's what I want. And over here, those guys were already there, and now he joined them. So now it looks normal. So then we can ask ourselves, all right, I need factors of negative 54, and I want a sum of 3. Maybe 9 and 6. 9 times 6 is 54. I want it to be positive 3, so I'll make him negative. 9 times negative 6 is negative 54. 9 plus negative 6 is 3. Perfect. All right, so we have t plus 9 times t minus 6, which means, since that's a positive 9, one of my solutions is negative 9. And since that's a negative 6, my other solution is a positive 6. The end. Save the application problems at the bottom of your notes. There's 3 of them. Save those for later, because those are kind of tough. So we'll do those together.